Okay, let's take a look at question 2b. This is question 2b from the 2010 scholarship paper. And upon initial inspection, it looks just like a nice straightforward titration slash qualitative quantitative analysis question that you would have had in level 2 even. And I suppose the first part of it is, but to actually determine the percentage of sodium chloride in the mixture, the second half of the question is essentially algebra. So I had to do a little bit of revision of that, admittedly, because it's been a long time since I did some of this algebra. But if you bear with the question, it's quite doable once you know how to do it, obviously, and then hopefully this will help you out if you get similar questions in the future. So 0.746 grams of a mixture of sodium chloride and potassium chloride. So we have two sources of chloride ions here, sodium chloride and potassium chloride. Was dissolved in water and made up to 250 mils of solution in the volumetric flask. A 50 ml portion of this solution required 25.6 mils of that concentration of silver nitrate, which is AgNO3, solution for the titration to reach the endpoint. Calculate the percentage of sodium chloride in the mixture. And this is uniquely sodium chloride, not just chloride ions, not potassium chloride. It has to be sodium chloride, so bear that in mind, not those things there. So we can draw a quick little diagram just to give a bit of an illustration for what's happening. So they were dissolved in the volumetric flask, which is one of these things right here, set to a fixed volume, and inside we had 250 mils. So this is a 250 ml volumetric flask, so it would have been made up to the line here, and that's 0.250 liters. And then in that we have sodium chloride solid, which has been dissolved, and then we have potassium chloride solid, which has been dissolved. And the total mass of those two things was 0.746 grams. And then we take 50 mils off that, so we take a 50 ml aliquot, put it probably into a conical flask, and that we have 50 mils right there. So we've only taken a fifth of the original volume there, just to bear that in mind. And then we titrate that with a particular concentration of silver nitrate, AgNO3, which has a concentration of 0.0970 moles per liter, and it takes 0.0256 liters or 25.6 mLs of a titer. So the equation for what's happening here with the titration between silver nitrate and your chloride ions. So the equation for this reaction between silver ions from the silver nitrate and chloride ions, which came from the NaCl or the KCl association in water, is silver ions aqueous plus chloride ions aqueous form silver chloride solid. And you should remember this from level 2 with your ions in solution. Silver chloride is a white to pale yellow precipitate. And from that equation, you can see that 1 mole takes 1 mole of silver ions to react fully with 1 mole of chloride ions. And then we're assuming that the sodium, potassium, and the nitrate ions are spectators. So we didn't include them in the equation. If we scroll on down now, we want to work out, first of all, the moles of silver ions, which is equal to concentration times volume. The concentration of silver ions is up here, so it's 0.0970 moles per liter, by the volume needed in the titer, which was here, 0.0256 liters, and that gives us moles of silver ions of 0.024832 moles, which could be rounded up to scientific notation written as 2.48 by 10 to the minus 3 moles. Just matching that up with what the NCA guys were using. So that's the moles of silver ions, which is also equal to the moles of chloride ions. So the moles of chloride ions, 2.48 by 10 to the minus 3 moles. And that's in your 50 ml aliquot, which was in the conical flask. That's in your conical flask right there. You have 2.48 by 10 to the minus 3 moles of chloride ions. And to work out the concentration of chloride ions. So the concentration of chloride ions, using your concentration equals moles over volume triangle. Concentration equals the moles divided by the volume. So in this case, the concentration of chloride ions, because that 2.48 moles was in 50 mils, so then it's moles, 2.48 by 10 to the minus 3 moles, divided by the volume, which is 0.050 liters, and that gives you a concentration of chloride ions per liter of 0.04966 moles per liter. Now, in the question, they're asking us for the percentage composition in terms of mass, because the original mixture was given to us as 0.746 grams. So we need to get this amount of chloride ions in mass. So mass of chloride is equal to the mass of chloride ions, that's equal to the moles times the molecular mass. So that's equals to now, there's something we forgot to point out here, that this is the number of moles of chloride ions, 0.04966 moles of chloride ions in a liter, but we didn't have a liter, we had 250 mils, so 0.0250 liters, which is a quarter of a liter. So in a quarter of a liter, the moles of chloride ions that we have present, just get a red pen here now, make this correct correction. So the moles of chloride ions in 250 ml is equal to a quarter of what we'd have in a liter, which is equal to 0.0124 moles. So this 0.0124 moles, now to get we use this to get the mass of chloride ions, and this is in 250 ml sample, in the 250 ml volumetric flask. So in the 250 ml volumetric flask with a mass of with a mole of 0.0124 moles, the mass can be calculated. Mass of chloride ions is equal to the moles times molar mass, which is equal to 0.0124 moles, multiplied by the molecular mass of chloride, which is 35.5 grams per mole, and that gives you a mass of chloride ions in 250 mils of 0.4402 grams. So that's the first number that you needed to get. You're sort of about a third of the way through this question, I suppose. That's the mass of chloride ions. And we're going to use that number to work out our algebraic equation to work out the values for the mass of KCl and the mass for NaCl. Okay, so I've just started a new page now, and we've just discovered that we have 0.4402 grams of chloride ions in the 0.746 gram mixture of sodium chloride and potassium chloride. However, we need to find the percentage composition of sodium chloride, not chloride ions, in the mixture. So to do this, we're going to write a series of expressions, and basically what we want to do is we want to work out the mass of chloride ions in NaCl, plus the mass of chloride ions in KCl, and let that equal to the total mass of chloride ions, which is 0.4402 grams. So that's the gist of it. So we need to work out expressions to represent the mass of NaCl and the mass of KCl. So what we're going to do is this. So if we let the mass of NaCl equal to X grams, that's the ultimate thing that we want to find. We want to find the composition of NaCl in the mixture. So the mass of NaCl is represented by X. Then the mass, if the mass of NaCl is equal to X, then the mass of KCl is going to be equal to 0.746 grams, which is the total mass of the mixture, minus X. We'll just keep the units there beside it. So how do we do this? Well, the moles of NaCl, we know they're going to be equal to, you want to just keep these little triangles beside you as you work. So moles of NaCl, moles are going to be equal to mass of NaCl over the molecular mass of NaCl. So the mass of NaCl, which we just said was equal to x grams. So that's x grams divided by the molecular mass of NaCl, which is 58.5 grams per mole. So that would be how you'd represent the moles of NaCl. Then the mass of chloride ions within NaCl is going to be equal to, well, mass, in this case, we rearrange this, mass is going to be equal to moles times molecular mass. So the moles of chloride ions can be simply taken by taking the moles of NaCl because it's a 1:1 ratio, 1:1 right there. So we take x grams over 58.5 grams per mole. We've just written this already. That represents the moles of NaCl. We've just got that from up there. So mass equals moles by molecular mass. In this case, it's going to be 35.5 grams per mole because we're interested in the mass of chloride ions. So we use the molecular mass of chloride. So that's the molecular mass right there of chloride ions. So that's your moles times molar mass. So that's how we represent the mass of chloride ions from NaCl. So that's one of the first things we were looking for up here. That's number one. So how do you write the expression for number two? Well, same approach. We scroll on down a little bit. I want to maybe just see that in the shot. I didn't want to scroll down that much. Okay, so I've made the screen a bit smaller so we can just have these two expressions beside each other. And we've just done an expression for the mass of chloride ions. The next thing is an expression for the mass of chloride ions in KCl. So the moles of KCl, similar idea to before. Remember, it's a 1:1 ratio there. So it's going to be equal to the mass of KCl. So remember, moles equals mass divided by molecular mass. So the mass of KCl, we said, was going to be represented by this. So that's equals to 0.746 grams minus x grams over the molecular mass of KCl, which is 74.6 grams per mole. So that represents the moles of KCl right there, that expression. And that was mass over molecular mass. Okay, so the mass mass of chloride ions in KCl, well, mass again is equals to moles times molecular mass. So it's all of this stuff multiplied by the molecular mass of chloride ions. So it's 0.746 grams minus x grams over 74.6 grams per mole multiplied by 35.5 grams per mole. So that's the molecular mass of chloride ions right there. And this is the moles of KCl. Or you could simply say the moles of chloride ions in KCl, more specifically. So then to get the total mass of the mixture, you need to add expression number one to expression number two to give you 0.4402 grams. So what I'm going to do is I'm just going to highlight these two expressions. I'm going to be taking this expression right here. Take a line just to show that. Use this expression right here. So the mass of chloride ions in case NaCl, take that expression plus this expression, the mass of chloride ions in KCl. We add the two of them together, like here, add those two together and let them equal to 0.4402 grams. So I'm going to do that now on a clear new page. Okay, so I've rewritten the two expressions here for the mass of chloride ions in NaCl plus the mass of chloride ions in KCl. So you should recognize those two expressions from what we've just covered. And the mass of chloride ions from NaCl plus from KCl added together gives you your total mass of chloride ions, which we found in the first part of the question. So the point here now is to work out the mass of, well, what is the value of x? If we work out the value of x, remember x equals to the mass of NaCl, and that's what we're interested in from the exam question. So we need to do a little bit of algebraic manipulation here. And what we do is if we just multiply everything by 35.5 there and everything by 35.5 here, then the expression becomes 35.5x over 58.5. The units there can cancel with each other, by the way. Those units cancel out nicely. So it's 35.5x over 58.5 plus 26.483 minus 35.5x over 74.6. So all of that is still equal to 0.4402 grams. We take the page down a little bit now. If you divide 35.5 by 58.5, you get 0.6068 grams, x 0.68x, which is in grams, plus your in this case, you divide that by that and that by 74.6 as well, you get 0.355 minus 0.4759 x, which is in grams, and that's equal to, you're still equal to 0.4402 grams. So then you end up with 0.1309x is equal to 0.0852 grams, and therefore x, which is the mass of NaCl in the mixture, is equal to 0.651 grams. So we're on track now. You can check that answer. The answer from the NCA guys, they get 0.055 grams, but that's because they worked out a mass for chloride ions of 0.441 grams. So slightly different, but not that far off. So 0.651 grams we get here. And then for the percentage of NaCl in the mixture percentage composition, it's simply just take the 0.651 grams, put it over the 0.746 grams, and that works out to be 87.3%. And that's how you do question 2, part B for the 2010 scholarship paper. So as I say, very tricky if you don't remember your algebra, and then it would take a competent student to take on with writing that those expressions. But once you've done 1 or 2, you should be able to do them in the future.